Hello and welcome. Good morning, good afternoon, good evening, wherever you are in the world. Today we have a LinkedIn live stream ready for you around knowledge graphs for next level cyber threat intelligence. If you're like me, I'm new to the cybersecurity, but I'm very excited to learn from Ryan and Jans what innovations are coming up in cybersecurity powered by semantics. So with that, we're going to allow our guests to do a little bit of a self-introduction, and we'll do it in alphabetical order, starting with Jans.
Well, I'm the CEO, CTO of Franz Inc, right? And we've been working on this AllegroGraph knowledge graph platform for the last 18 years. And happy to show you today what we can do.
Thank you, Jans. Steve? Oh, RS. Ryan. Sorry.
Alphabetical order. What school did you go to?
I get the three R's: reading, writing, and arithmetic.
Last name, first name, who knows what alphabetical. So I'm Ryan Hohimer. I'm an ontologist here at Semantic Arts. I've had a career that's taken me through the national lab systems for nearly 20 years, working in national security. Then I did a startup company for the years following that. Again, based in cybersecurity with graph-based analytics for the basis of that startup. And today I'm working at Semantic Arts, again, back in my passion of cybersecurity. And, what we're going to show you today is, pretty exciting for me. So that's who I am, an ontologist in cybersecurity.
Yeah, well, quickly, I'll go next. Steve Case. I'm with Semantic Arts as well. Been with them for about 5 years as our data-centric ambassador and lead some of our business development. And this is really a fascinating topic. I think that cybersecurity is trying to solve this for a long time. And this convergence of ontologies and knowledge graphs and graph RAG is really an innovation that is an exciting point right now. So I'll let you guys continue.
Just a quick thing before we get started. There's an article in the description of this live stream. So if you haven't gotten a chance to read it gives a further explanation into some of the subject matter we're going to be covering today. But with that being said, we're going to share Ryan's PowerPoint presentation and let him get started.
Yeah, I'm not going to kill you with the PowerPoint presentation too much. I want to get to the actual demonstration of what we have. This is not vaporware and it's not slideware. So, but I do want to set the stage to let you understand what it is that we're doing here. So we're introducing just cyber. It's a subgist. Gist is the upper level ontology that Semantic Arts offers. It gives a minimal ontology for business purposes. And we've extended that so that in the vertical market, every business has got to worry about cybersecurity. So we've extended it with the concepts that are most relevant to an enterprise trying to protect themselves. So why just cyber? In cybersecurity, there's this concept of a pyramid of pain. What we mean by this is that every enterprise needs to protect themselves from the bad guys, the bad actors, the threat actors, the attackers. And it's easy, there's some easy stuff to do to protect yourself against the attackers. We can run antivirus software, we can check our systems for the presence of IP addresses we know are malicious. We can check for the presence of domain names, our systems connecting to these command and control IP centers. So there's hygiene, there's security hygiene that we can do that's fairly easy. We've got tools to do this. But it's really difficult at the top of this pyramid of pain. It's really difficult to protect yourself against the adversaries who are sophisticated. They've got great funding from either the nation state, or they've been successful and are well funded within themselves, and they've developed techniques, tactics, and procedures, TTPs, that are sometimes proprietary to them. Sometimes they've discovered what they call 0 days, ways to attack us that nobody's ever seen before. And so these are really, really difficult to protect ourselves against. So the pyramid of pain is something we refer to when we're trying to apply this to how do we protect ourselves from the threat actors that are out there. But those threat actors have got an adversary, which is us, the defenders, right? So they have the same pyramid of pain, but in the inverse. They can easily attack us where we haven't been mindful about our cyber hygiene. We haven't trained our employees well to know to avoid those IP addresses and domains and phishing exploits that they might do. As well as what's very difficult then for those attackers is to understand our enterprise's techniques, tactics, and procedures to do business, to do the business functions that we need to do. So the threat actor's adversary is us, the defender. It's the network in between us, our interactions between those threat actors and our enterprise that is the battleground that we're talking about. I'm a big Sun Tzu fan, so if you know your enemy and you know yourself, you need not fear the result of 100 battles. This is the kind of thing that, just look at that quote. If you know the enemy and you know yourself, you need not fear the result of 100 battles. It's about knowledge about your enemy, knowledge about yourself, and that's where knowledge graphs come into play here. This is really important, to store your information and store the situation in a knowledge graph. There are many different domains of discourse. There are many domains within cybersecurity. You think about it, here in the center of this Venn diagram I've created is the enterprise itself. Well, enterprises are there to do business. They have business process. So they run on assets and hardware. That hardware runs software that has vulnerabilities. A type of software from the adversary is a malware. That malware is part of the library of techniques, tactics, and procedures that they have. And in the event that we detect any of these malicious activities on our network, we want to apply the controls and mitigations and be resilient to this situation. So the point being is there's many different domains of discourse. And here's some good news. There are many resources available to us from NIST and from the national lab systems like MITRE and our government agencies that have provided tremendous amounts of reference information that's available to us. Most of it, until just recently, most of it is human readable, but we need to get it into a democratized form that's machine readable, right? Because we got to tip our hats and give credit where credit's due. Our cybersecurity analysts of today are extremely knowledgeable, but they have to be really on top of their subject. And all of that information about those resources and what is available, for the most part, they keep in their head and in spreadsheets. And so we need to move this into a machine readable form that we can do graph analytics on this. The good news is there's a lot of it out there. So you've got standards like the STIX. Well, I'm going to talk a little bit about STIX later. You've got our National Institute of Standards and Technologies. We've got companies out there like Tenable that makes available vulnerability scans, and we've got Center for Internet Security, which gives us, the critical 18, the critical vulnerabilities, if you will, that we should be mindful of. There's a lot of resources available to us. What we want to accomplish and what we're doing with just cyber is we're bringing a common language to bring all those dispersed data sources together under one language. So we don't have one group referring to the bad guys as threat actors and another group referring to them as advanced persistent threat groups. We're going to bring them together so that we unify those concepts. And this is what brought us to the point where our founder and owner at Semantic Arts said, we really should bring just cyber to bear. We've been successful over 20 years with development of GIST. It's been useful, proven. Our client base is really needing the same extension into cybersecurity. It's one of those horizontal markets. It isn't like certain companies have to deal with cybersecurity. We all have to deal with cybersecurity. So let's make an offering that helps unify that language for the businesses. So I don't recall the exact date, but Dave called us together in a meeting in Chicago. We met there. That's Dave. He's our founder, owner that is at that whiteboard there, and we're discussing that pyramid of pain that I was talking about earlier. How can we best encapsulate the knowledge that we have about this domain in an ontology to govern a knowledge graph? And then Jans, who you'll be hearing here in just a bit, a quote that I pulled from him. These semantic knowledge graphs are really going to be the basis of the future of where we need to go in many of these domains within cybersecurity. In other words, it is these semantic knowledge graphs that give us the connectivity, create a harmonious data fabric that we can query and understand not only just the data available, but how that data relates to one another, the semantics behind that data. So as I've become more familiar with Jans and developed the friendship and the offerings that he and his company have, you'll see him in just a little bit, but really impressive. I want to talk a little bit about the STIX language, or the Structured Threat Intelligence Exchange language. So this was a language that came about that was developed mostly by domain experts in cybersecurity. They wanted to, and the government, even through executive order, said, if you're going to exchange threat intelligence amongst yourselves, we need a way to facilitate that exchange. And so they developed the STIX language. It is just that. It's an exchange language, a protocol to exchange information. So it isn't semantic interoperability, but it is interoperability. Let me share with you in a known format the things that I think you will find useful and relevant. The thing about the STIX exchange language, because as I said, it was developed mainly by cybersecurity domain experts, the concepts are fundamental and wonderful, but they're not represented in a formal ontological language. And so, although they were domain experts, they weren't knowledge representation and reasoning experts. And that's what we wanted just cyber to be, that formal ontological representation of this domain knowledge that was there. STIX defines 18 basic concepts. from attack patterns, vulnerabilities, what's malware, what's the infrastructure, what's an indicator. Indicators are a big thing in STIX, courses of action, campaigns. These concepts, because this is an exchange language and because this is highly used by our community, just cyber must at least give a comprehensive understanding of these 18 different concepts. It's going to go much beyond that, but these 18 different concepts need to be represented. The STIX language, although not a graph, not an ontology that governs a graph, loosely, I won't say directly, but it is more like a labeled property graph. So those of you that are listening today, if you are familiar with the STIX language and you're familiar with the graph representation types, you'll find that the original specification for STIX 2.1 most closely resembles a labeled property graph. And I can talk more about that if people are interested. But I want to talk about the basic building blocks of just cyber first. And what we want to do with just cyber, and what we're doing, is we're looking at the subject matter experts and their understanding of what threat intelligence is all about, what risk is involved with an enterprise, who the adversaries are. As much tradecraft about cybersecurity as we can needs to be represented in just cyber. But we also know that there's this STIX language, which has become the de facto way to exchange this kind of information between institutions. And so we built just cyber to be overarching, an umbrella over those resources that we have, and put it into a formal ontological language. And that's what we're making available to the community, to the public, is that they can use just cyber and a representation of their enterprise to understand how their enterprise relates to cybersecurity. So the first thing we need to do in that kind of situation is to get all of this reference data from those many different sources into a knowledge graph governed by just cyber. And here's an example of where we've done that. We've taken a report from, I think this is a report from Palo Alto's Unit 42, but it was, I'm not sure about that, but I might be from a friend of mine. I apologize. But there was a STIX document that was about Olympic destroyer campaign. This is the 2018 Olympics that ultimately was attacked and compromised. And so this is a STIX exchange document that we converted and used to populate a graph governed by just cyber, so that we can get a visual representation of the graph itself. Again, just to emphasize, we're getting data into this knowledge graph that we're gonna be talking about here in just a moment. It's coming from the National Vulnerability Database, the CVEs. These are the common vulnerability exposures and enumeration, CVEs, CWEs, common weakness, the common attack pattern enumeration and classification data set. These are all coming from different sources. The MITRE's attack framework, very predominant and very useful in the cybersecurity communities. And although I didn't bring it into here, there's another MITRE defend ontology and knowledge base that is becoming extremely useful. But we, through just cyber, we're bringing all of these data sources together so that we can communicate between them, so that we can understand the logical connections between concepts. Why would we want to do that? It's what cybersecurity analysts call connecting the dots. To go from understanding that there is a vulnerability on a system to understanding that that vulnerability relates to a a weakness, and that weakness relates to an attack pattern. And there's several different representations of attack patterns, and those attack patterns relate to what they call intrusion sets, or representations of the capabilities of the threat actors in the system. We want to be able to recognize, hey, in our enterprise, we've got a vulnerability. Who might be capable of exploiting that vulnerability? Or the inverse, a CEO might walk into the CISO's office and say, hey, I've just been watching the news and I see that APT29 is active. Are we at risk? You know, those kinds of questions. You know, APT29 is a Russian group, a Russian adversarial group, and you know, the CEO is interested. You know, given the market sector that I am, are we at risk? So those are the kinds of competency questions that we'd like to have these graphs be able to answer for us. So, and I guess here it is, I got a visual of exactly that. Given a particular CVE that I know to be on my system, who might be the threat actors or threat groups that would be of concern to me, so that I can familiarize myself with their techniques, tactics, and procedures so that I can protect myself against that. I may not have been thinking about it before. Now I am. What do I have to do? What controls and mitigations can I put in place? So here's one. Mandiant put out a report. This is the example of a report that they put out about the Clop ransomware gang. And all the activity. This is still active today. But what we need to do is move from depending upon these human readable reports and move it to, I can see I messed up my slide, but move it to a graph representation. So with that, I would like to show that this is not, on our part, this is not just vaporware. Here I have loaded, this would be good to show. I have loaded, and it's going to be fine print. I don't know what you guys will have to do that. But I've loaded from all those different sources we've been talking about. This is just reference data. So this is reference data that I have loaded in. So we've certainly loaded in just cyber, and I've loaded in that common vulnerability and exposure data and common weaknesses. I've loaded in GIST, and I've loaded in what else? The attack framework, all of those. I've loaded all that reference data that we've converted from the databases and sources and placed it into this knowledge graph so that we can explore it. And here's a representation of AllegroGraph, or this is AllegroGraph running over that knowledge base that we have, that knowledge graph. And we can use this to form queries, just like the one that we had on the slideware. In other words, if I know that I've got a certain CVE, a certain vulnerability, in this case, the vulnerability from 2023, 28,512, if I've got that vulnerability in my network, what intrusion set, what bad actors might I be concerned with? So we can create this query, and it's a visual query that has been created. I can run this query, and it will give me a result set. and I can review that result set in graphical form. So we'll repeat that. I've got a visual query. I can run that query. I noticed I was only getting intrusion sets there. So what I'm going to do is say that I want to see everything that is being exposed in that query, and then create a visual graph of that query. So I can see everything from that original CVE through to the attack pattern that was used. It was used in a campaign, and there are six different intrusion sets that include this malware that is involved in this attack involving that particular CVE that I've got. So we can start exploring this if we wanted to, and this is something that I'm learning from Jans. This tooling that they put together is incredible. I can learn. Well, tell me more about this intrusion set that has been. That I can get a full description of this particular intrusion set, or if I want more information about this attack pattern, I can look at all the data that's associated with this particular attack pattern. So this graph has got an incredible amount of information in it, worth our ability to explore. Of course, at the high level, just knowing, hey, I've got these CVEs, I've got these vulnerabilities on my network. Who might I be interested in protecting myself against? Or, there's a tremendous amount of information here. And I guess with that, I'm going to let Jans take it from here and talk to us about some of the usability, some of the capabilities that he'll bring to bear on this knowledge graph.
All right, thanks, Ryan. Any questions so far, or do I just dive into my presentation?
If you have any open questions, please put them in the comments section. We'll address them as they come in. Otherwise, Jans, I would encourage you to dive right in, and as we get questions, we'll answer them.
Yeah. All right. So Ryan and his colleague Cotton did an enormous amount of work to create this structured knowledge graph. But one thing I see with almost every knowledge graph that we work with is that half of the data is in unstructured text, sometimes even more. And in many cases, all the juicy parts, right, are not in the structured data, but actually in the underlying text. So in this database that Ryan created, there's 1.2 million triples, but about 120,000 of these triples had pretty large literals, string literals, right? And a lot of very interesting information is in those literals. And so I did what I think is the future of every knowledge graph that you guys are going to work with in the future, is that we take every string in your knowledge graph and put it into a vector store. I'm kind of assuming by now everyone knows what a vector store is, and I'm also assuming that everyone knows what RAG is, right? I don't have to explain that. But basically, one thing, so we take every string, we send it to an LLM like OpenAI or Claude, and OpenAI, and we get a vector back, and that is the thing that we call an embedding. So here is an example where we say, okay, so we have, this is something I just came up, right? Misuse of process trace, just a single string, right? And I say, in all the strings, in all the 120,000 strings that I have, which strings are the closest or semantically the closest to the little string misuse of process trace, right? And use Cyber Ryan as the vector store, right? And on the left-hand side of this magic predicate nearest neighbor, what we get back when we do this query is a URI that points to the embedding, meaning the 1536 floats, the dot product, right, or the cosine distance between a term and the thing you're looking for, and then the term that we find in the database. So I'm looking here and I say, okay, let's do this, and I find the terms that are the closest with this thing here, and you see here the semantic distance, and you see the embedding. Now, if I click on this embedding, then you see that it's actually related to an object that Ryan showed, right? And this object is a STIX object, and the text is monitor for process being viewed that might inject malicious code into processes via ptrace or process trace, right? So that is the simplest. But in the knowledge graph, there's about 20 classes, and I think about 10 of them have interesting strings. So where do these strings appear, right? So I can actually do the next question, the same question, except now I say, okay, given the embedding that I find links to a thing, and what is the class of the thing, and give me the distinct classes. So do the same query, but now I want to know where the strings that matched came from, right? And I execute this, and I find that there are attack patterns from the KPAC database, there's GIST techniques, templates, attack patterns, and then other domain objects, right? And these are kind of abstract types because Ryan did a lot of reasoning on the database, but for now they kind of distract from the fact that there's a few interesting classes, right, where these strings came from that matched this string. So now let's go a little bit deeper, right, and look like where we select. Okay, let me say this. So you do that, you find the embedding with RAG of the nearest neighbor, but sometimes you want to only find a match of a term like this in one particular class, right? And so we know the classes now. So I can say, same question again, right? Find the nearest neighbor, cyber item, except only match against things that are a GIST technique, right? So now we're getting into the graph reg domain. We still do nearest neighbor, but we want the strings that we get only from a subset of our data. Very, very important to realize that, right? Because otherwise, if you just do RAG over a massive amount of data, then you get answers from many different places. And sometimes that's fantastic because you wanted to find that one string. And sometimes it's completely inappropriate because it was not the thing that you wanted to match with, right? So here I do this one, right? And now I get only terms that come from the class technique, right? And of course, I could change this into anything that I wanted to, right? So I could do attack patterns, intrusion sets, or what have you, right? Now, by the way, this selector thing, so basically what you see here, you have a sparkle clause, right? And then here you have a selector, and this thing is a complete normal sparkle queries. You could put anything you want. So here we have another one where you say, well, I want to match this term, right? But I only wanted to do it in intrusion sets where the date is before 2022, right? So you see how very detailed you can tell the system where to look for strings that you're interested in, right? And so I can execute this one, right? And now by the way, you see here the number 3.1, which is, by the way, if you actually were going to read the texts here, then you see they don't get very close to process trace, right? That's because the numbers are very low. So if I would do min score, let's say 0.5, which for the embedding model I'm using, then I wouldn't even get any information, because things about process traces are usually not specified in the intrusion set, but in something like the technique or the weakness, right? So anyway, this is nearest neighbor. And then we have the next thing that we can do, and that is we can actually ask for answers in our RAG system, right? So how this works, is where you can, what's happening here is we have a magic predicate called ask my documents. You ask your question, who is affected by log4j, right? And what it will do, it first does a nearest neighbor, and then based on the nearest neighbor, it will concatenate all the terms that you find together, and then you send the question who's affected by log4j plus the fragments that you found to an LLM, and it will find the answer in your fragments. And that is what LM Ask My Documents does. Does that make sense, right? Because, well, I hope this is clear. Does anyone need any questions about this part, right?
I have
Yeah.
a comment, because you were showing me this earlier. We've been working together, but this is cool. I don't need to know how to write these complex Sparkle queries. I don't need to know, the knowledge representation and reasoning components to query the knowledge graph here. I mean,
Yeah.
who's affected by log4j? That I didn't need any Sparkle or SQL or any of that. It's just your practitioners can make great use of this.
Yeah. Well, so here's another example, right? What are some of the bad actors in Eastern Europe, right? And only look in the intrusion set, right? That's what you do here. So this predicate ask my documents, again, you can control where you're going to look for answers. And when I look here, right, what are some of the bad actors? It will find this group here, right, attacking financial institutions in Eastern Europe. And obviously I could change it to anything I want, right? So if I want to do it in China, right? Back to that attack, whatever, financial institutions, right? Institutions. And if you wait, and here you see APT19, right? APT19, a Chinese-based threat actors targeted multiple industries, blah, blah, blah. Notably impacting investment firms. So that is kind of close to the financial part, right? Again, so now, but what you see here, I'm still kind of writing Sparkle queries, right? Except I'm asking meaningful questions about unstructured text in here. Now let's go to the next part where we do natural language queries, right? So let me just go here and I say natural language to Sparkle, right? And I can ask anything about the structure of the database, just something like how many triples do we have per named graph, right? And I can ask this, and it will find it, right? Or if I wanted to do the order by descending count, right? So, oh, by the way, one of the things for those people here, most people here are interested in cyber security, right? And not so much people interested in knowledge graph. But for the few people that are really interested in knowledge graphs, one second, this is taking a little while.
Yeah, this is really cool, Jans. I mean, this
Okay,
is.
yeah, here it is, right? So I did this. Now, by the way, for those people here interested in knowledge graph, this, when we do something like this, right? Actually, we do two things. One, we had the system create shackle, right, over the entire knowledge graph. So here are all the the shackle shapes for every class that we have in our database, right? And so every time we do a prompt, we give all the shackle to an LLM, right? And then the other thing we do, every time we have a successful query, we can save it to the natural language, save it to an underlying vector store, so that the next time, every time we do a query, we also give you all the successful queries. So here I have also a whole database of queries that were successful, right, that I played with, and that I used as example to create the next query that you might have. Right? So anyway, let's get a little bit more into the world of cybersecurity. So, for example, I could say, show me a few intrusion sets, right? And here I get the sparkle, right, for this. And here I get the answer, right? So again, this is way easier than writing the sparkle here, right? I could also say, show me, say, 20 intrusion sets, right? 20 intrusion sets. And I don't know. So now it has to think. The previous query was in the database. This one was not in the database, so it had to create it, right? But now I get limit 20. Does it make sense? Or I can do something like, okay, show me intrusion sets that have a STIX creation date before 2022, right? And I run this as a query. Let's see.
I don't think I gave in the graph I gave you. I don't think I gave you anything. Well,
Yeah.
there you, oh, it's the STIX creation date. Correct. Okay.
Yeah. So here's the DH. Yeah, that's why I asked for. Yeah, you're right. I mean, this is not the date of when the intrusion set, because we don't have the information, right? But I just wanted to show the principle of it, right? I mean, I can also say after 2021, right, and run it. And again, this beats writing it by hand, right? I think in 10 years we'll tell our children that in the old days people were really writing Sparkle and SQL queries, right? They can't even imagine that anymore. Okay, so now I can do, okay, show me, let's say, show me a few examples of an intrusion set where the description contains the words Korea, right? And run this. So now it is to figure out where the descriptions actually are, right? And then you see the intrusion set, the name of the intrusion set. Now, by the way, I didn't tell it to give me the name, right? But it thought it was fairly logical that it also got the name, right? So it kind of decided. Yeah.
Quick interjection. John DeSanto is asking, I may have missed this, but what is mapping the English to Sparkle? Is that a call to an LLM?
Yeah.
And then you said it's validated through Shackle validations.
So first what we did is we created a shackle for the entire database. And just for completeness, and then I threw out all the OWL class, the OWL intersections and OWL unions, etc. I just only kept the meaningful classes, right? So now I have a set of shackle, and I have a database of successful queries where I have the natural language description of the query and the successful sparkle. And so now when I do a query, the query will look in the database for the queries that it had done before that looked the closest like the thing I'm typing. So again, it uses the vector store to find queries that looked like the one I'm doing right now, right? As a help and all the shackle, and then I give it to an LLM, and then the LLM will write the sparkle. Now, the LLM will usually screw up the first time, pardon my language, right? And so it will try multiple times till it finally gets a result, and then it will come back. Or it will give me a list of queries that it couldn't decide, but it will give you an explanation, and then you can edit the query yourself. And then once you are happy, you store the successful example, and then you can use it the next time, right? Does it make sense?
Thank you for explaining. Yes.
Yeah. For example, I did something like say Korea or Belgium, right? And this is going to take a little while because this one is not in the, well, it has to figure out, yeah, oh, I did it right. So you see here, right? So the first time when I tried this, it didn't end. This means in our, so by the way, oh, sorry, I should have mentioned, right? So the LLM, we also tell the LLM about some of our underlying magic predicates, right? So they can use it too. So here it does an FTI match where you say, okay, find or anything that starts with Korea or anything that starts with Belgium in the index all, right? Anyway, I'm amazed how well it does this, right? But anyway, so we found in the previous query, right? Tonto team and dust storm. So just for fun, let's do this, right? Let's do this. Give me the description of the CVEs that the intrusion set dust storm might employ, right? So I do want to remind you guys that this actually is going to be a very complicated query because this one has to go. Let's take the depiction that Ryan created, right, where we go from an intrusion set to an attack pattern that looks like the one from GIST, right, which then links to KPAC, which links to a weakness, which then links to a problem type, but then to a problem type a problem type in a container, and then this container actually has a description here, right? So it's a whole bunch of joins that it has to figure out. So when I do the query and I run it, right? So it's going to take some time because, right? So, I mean, I want you guys to be very impressed now because the LLM managed to take all the shackle, it takes some examples, right, and created this pretty big query, right, to do. I mean, can you imagine that I asked you to write this query, and of course you could use in Graph our visual query language, right, to kind of do it, but I mean, this is way easier, right?
Well, you've impressed the heck out of me.
Yeah. And of course, this is dust storm, right? So if I could take any of the others, I can say the Tonto team might employ, right? And of course, so it's going to do the same thing, except we're going to do dust storm and probably change that in Tonto team, right? Because that's just a single replacement. But again, I'm doing all the work to send it off to an LLM, right? OpenAI, in this case, right, to get the answer back. And again, yeah, oh, this is fun. Okay, so here it didn't get it, right? Because why didn't it get it? Intrusion set the STIX. Here it says it couldn't do it. And the reason is the Spark of Natural fails because the clarification prefix ns this ask returns empty response. That is very weird. Anyway, I'm not going to do the debugging here, right? But this is the work of the future knowledge engineer, right? To go out, ask all stakeholders for questions that they might want to ask of the knowledge graph. The knowledge engineer will help the system write the queries to get huge training sets. So at some point, it should be completely automatic, if that makes sense. And okay, one more thing that I want to show you, and that is so we did RAG, right? But we can also do the RAG in NLQ itself, right? So for example, I can type here using RAG, right? What are the main bad actors in China that are attacking financial institutions using the information in intrusion sets, right? And then if we're lucky, right, it will actually write, oh, look here, right? Now, again, I think it's, if you just think of it, right, all the processes involved where it gets the shackle, and in previous examples, it goes back to the LLM and then comes back. But actually, the query that it generated does again a call to the vector store and to the LLM again, right? So it's like layers of AI in here, right? And then it gets.
So I wanted to make a comment here,
Yeah.
Jan, is we have been looking at the reference data
Mm-hmm.
that's available to us from NIST and,
Yeah.
and MITRE and National Vulnerability, all of these different reference data that we've pulled together and harmonized with just cyber.
Yeah.
Now, when an enterprise adds to this knowledge graph the specifics of their enterprise,
Yeah.
like what business sector they are in, what vulnerabilities they just, on this morning's vulnerability scan, I received these 5 vulnerabilities that are on my system.
Yeah.
Understanding that those new facts about the enterprise itself in reference to this reference material that we've been talking about for the last few minutes is extremely powerful because it helps the CISO make decisions. Oh, okay, we have these vulnerabilities, but the impact to my institution is low, or the likelihood of exploitation is low. So I don't need to spend precious resources on those today. It allows for decision making at the next level.
Yeah.
That's when you integrate this information with the information about the specific enterprise. You could start asking these natural language questions. Hey, I've just discovered, show me threat actors that might exploit the CVE I just found on, my report this morning, and they'll be able to get those answers. This is incredibly powerful stuff that you're showing us, Jan. And literally, you've only had this data for a couple of days, so I'm impressed as heck.
It is, yeah, it is very cool, right? But 3 years ago, the LLMs came out, and suddenly we can do all this stuff, right? It's just that is the amazing part, right? The industry is very, very quickly incorporating the LLM and vector stores and all of that in here, right? And I think it's especially knowledge graph that you need for this, right? Because otherwise it's just too complex if you would try this in a SQL scheme or anything. But anyway, I'm excited about this. I had 2 days. So this is.
We have a comment from Nelson Carmelino. He's saying translating the Sparkle to English using the LLM is democratizing the knowledge, and that's very important to allow communication between the cybersecurity teams and the company. And that's true. There are so many layers of complexity and abstraction that are being taken care of by the GIS Cyber integrated effort and this LLM interface through the graph rag architecture you've developed, Jans. I mean, it almost looks easy. It almost looks like this is something that is to be expected today for whatever reason, but it's not.
No, that's right.
Ryan, do you want to talk a little bit about some of the work integrating what you described were all these different levels of abstracting knowledge. You mentioned miter, attack, defend, all these different mappings. They weren't natively semantic represented models. You
No,
went and created the models yourself.
no, they weren't. So cybersecurity community has got some really, really intelligent people. That these people have been studying cybersecurity, practicing cybersecurity for years and years and years, and they've formed a vernacular, right? I mean, it isn't. Uh, we in the world, on the globe, how many different languages have we got? But we're communicating, basically the same concepts. It's just we're using different languages to refer to them. Well, that's basically what happens in any domain, and it's true of cybersecurity as well. So I may refer to something as a risk, and somebody else refers to it as a threat, and somebody else refers to, there's all sorts of different senses of different words, different contexts in which those words need to be considered. And so, but fortunately, over the decades in cybersecurity, they've formed kind of a language. I mean, humans are taking all this disparate information from different databases and reports. They're reading it, they're ingesting it, they're using it to interpret the situation at their companies. But moving it to some automated processes is absolutely essential. The amount of data that we have to, it's the big data problem of the late 90s and early 2000s. We started talking about the big data problem. Well, cybersecurity cannot be done manually anymore. It cannot be done without the aid of lots of different resources to automate the process. In the average SOC, the average security operations center for reasonable sized corporations, they'll have 75 or so different appliances to monitor for intrusion detection or data loss prevention, or FireEye appliances is one of the FireEye's one of the dominant ones. But there's lots of appliances out there, each with their own data model to accomplish the task that they're supposed to accomplish. So you get 75 different languages that you need to converge together so that you know that the results you're getting from one appliance relate to the results you're getting from another appliance in a logical form that you can make use of. So this is the at Semantic Arts, this is the idea that we try to put forward, that enterprises, businesses need to move to a data-centric sort of architecture. And what that means is bring all of this dispersed data under one model, instead of having a model in each of your different applications, each of your different appliances, each of your different locations. Bring them all together under a single model, and then have those applications query that single model. So for a data centricity, and I can't talk about that as elegantly as Steve Case. You can. You're kind of our data centric ambassador.
Let me feed on that a little bit, Ryan, and ask you an open-ended question about, like you said, lots of appliances, lots of tools in the cybersecurity, and it seems like they're only growing. So this interoperability that we're representing in an ontology in this common model, how is that going to help maybe reduce that footprint, or is it? Maybe you can talk a little bit more about what that means as far as we oftentimes call it the overarching simplicity that we're going to bring to a very complex problem.
All right. Well, I'm gonna answer it from the problem space that I've experienced over the time frame. The security operations centers around that I've been familiar with in the decades leading up to the current time, they've got a tremendous, huge problem in front of them. You're supposed to protect our enterprise, and so the CEO, the CFO, the CISO, in the boardroom, they're talking about, well, how can we do that? And the tendency is just to say, well, we have a problem. Let's buy the solution. Let's get another appliance. Let's do that. And some of those appliances are not cheap. They're expensive. So by moving to this data-centric approach, you can start to get somewhat of a capabilities topography of all of the data sources that you've got. Don't spend hundreds of thousands of dollars on another appliance that just gives you the same information you're already getting from one of your others, right? So there's an amount of knowledge that can be built in your knowledge graph that includes the capabilities of your own enterprise that can optimize where you spend your monies. Where do you want to put your resources? So there's the same thing in terms of not just buying repetitive capabilities, but there's also that savings that you get from understanding and having knowledge about the cost of responding to certain types of events, right? If I mentioned earlier in this conversation that I just ran a vulnerability scan. I see I've got 50 different vulnerabilities that I'm now aware of on my system. You need to be able to determine which ones of those are really severe and which ones are really likely to happen. The A definition of risk is the product of the likelihood of exploitation and the impact if that exploitation happens. So you can get a risk assessment. Understanding these things in a holistic fashion from your knowledge graph, as opposed to getting independent answers from different appliances, is a big deal. I think I may have made clear a very muddy. I think I may have made muddy a very clear answer, but there you go.
Well, I think that the bottom line here is that there has to be cross-organizational communication and collaboration. And what we're doing is we're enabling that with a data-centric architecture, because like you said, all these signals come in from these various different areas and nobody knows exactly how they all kind of fit within the bigger picture. And that's what this is representing. Joaquin, I know we're kind of short on time. Any other questions in our chat?
Yeah, I wanted to make mention 2 comments, and I think the first kind of was addressed throughout Jan's demonstration of what's already possible. Lance et al. But I can imagine the thread mapping eventually gets verbose enough to link a code execution path or even a transaction to actually identify attackers in real time. Yes. I mean, right now, this is sort of the alpha version, and it's only getting more potent and mature as Ryan continues to do his mapping work. So, yeah, this is as early stage as you're going to see it. It's only going to continue to get better from here on in. And Jans was taking the care to show us the various capabilities that this natural language processing interface allows us to do through different kinds of criterias that we're looking through. But he was executing them manually. Now imagine if he had a predetermined checklist of things to check for and execute upon uh, at a regular time interval. Then you have a watchdog that's working around the clock that's plugged into those 75 applications without asking for sick time or vacation time, or you have some serious sentry system set up for that.
Yeah, pretty fascinating, Joaquin. And I don't know. I was just going to end up with one last question for both Ryan and Jans. And obviously, we're at this exciting convergence of AI, knowledge graphs, and cybersecurity. Where do you see organizations starting to prepare for this future? And any suggestions along those lines?
For who is this?
Go ahead, Jans, if you want, or I can start.
You start. I'll end.
We have a philosophy at Semantic Arts, and that is think big and start small. And so if you're an institution that is starting to ponder your cybersecurity stance, you can probably start out in the same way that everybody else is, and start going out, buying the appliances, hiring the analysts, and doing that. But in that approach, we would encourage you to start using knowledge graph capabilities, particularly under just cyber that we're talking about, and start to equate your enterprise's data, your enterprise's knowledge graph and systems, your business models, and that in the knowledge graph, so that you can start comparing it to the outside world. So if you're already an existing enterprise with an existing SOC, then this is one of those things. It's not an appliance, it's a philosophy, it's a way of doing business that you can start to apply. And again, think big, think about the capabilities you've just seen in the last hour, and start small and start applying that system at a time or component at a time, and let it grow from there, because you'll find that it becomes extremely powerful, particularly in the reduction. I'm sorry, you hit my hot button here, Steve. False positives. Cybersecurity centers are riddled with false positives. They get all of this information coming in from all of these different sources, and 90% of it is a false positive. It's something you shouldn't waste your time on. So use the knowledge graph to logically understand and narrow down your many, many false positives to just those true positives that you should pursue. So how does this go in relationship to your answer? If you're an established security operations center or established security center within an institution, and you're riddled with false positives, consider using this technology to start eliminating that pain point that you have. Think big and start small.
And so, Ryan, you stole what I want to say, right? I mean, in every company that I've been into, there's always this first little use case that's very, very straightforward to do, right? And people in the organization have to see the advantage of this approach. So really find the low-hanging fruit, do the first POC, and work from there. Doing this top-down massive plan never gonna work. Just try something that really helps your SA people, right? And then take it from there.
There's just one more comment, one more question, and we can disambiguate this thing and close the live stream. Lance Edel states one limitation he anticipates is that knowledge graphs aren't the best for storing large transaction sets. However, the RAG concept may work to link out to transactional data stores to minimize the growth of the graph with transactional data. Jans, do you want to address that from your developments with AllegroGraph and how you're tuning it?
Well, you can put 100 billion triples in a sharded version of AllegroGraph, right? But it's a good point. What you want to use knowledge graphs for is knowledge, right? Much better to keep all the transaction data in the data where it's sitting right, log databases, and the metadata about events, right? And the things you can learn from those large transaction database. That is the knowledge that human beings wants to see, right? And so you put that in your knowledge graph with backpointers to the transaction database, right? Where the records were that say something important. But it's kind of nonsense to take log files and put those in knowledge graphs. Knowledge graphs are really about knowledge, like in many cases, kind of how people think, right? And you just keep the data in the transaction database. The knowledge graph has to take care of all the intelligence, right? And by the way, there's amazing, huge vector stores out there, right, that can do billions and billions of transactions easily, right? And again, the knowledge graph can talk to these external. We have an internal vector store, right? You've seen it today in action, right? If you start to talk about 10 billion log elements, right? Use something like Vespa or whatever you have, right? Pinecone or something. Yeah, just as a to load, because you only want to focus on the intelligence.
Yeah, you make a great point there, Jans. And sometimes people get confused by the data-centric nature of the term. So it's not putting all the data in one place. It's basically, pulling out and extracting that meaningful aspect of those data that is useful for you at any particular time. So it's more purpose-driven approach as to how you look at it.
Yeah. And even that can run into billions, by the way. If customer, but just the metadata is 6 billion triples, right? Right. And the actual documents are in different databases, but that's fine, right? The reasoning happens in the knowledge graph.
Indeed.
Yeah.
With all that being said, thank you very much for attending this live stream. Just to be abundantly clear, this is an extension that is not yet made public, just cyber, but the GIST core is publicly available for your use, and you can crack it open, download it, and do whatever you'd like to do with it. It's open source. The solution that Jans was demonstrating today is also not available for public use as of yet, but we're happy to have any dialogues if you're interested to learn more how we can implement this in your organization. So,
and if you want to help, right?
If you want to what?
And if you want to help, there's so incredibly much work to be done, right? So
that's right.
Just reach out.
Yeah.
All right. Thank you all.